Hey, hi guys, welcome to my YouTube channel. So last class we have detailedly discussed about how the energy band is formed when there is an interaction with n number of atoms or n number of pieces. So how the energy level is getting splitted into energy band, that thing we have seen. So today, in order to test your knowledge, I have prepared one small question for the understanding purpose. The question is consider the energy band formation in silicon, then the number of states in the valence band and condension band for n number of silicon atom in interaction. So given the observe the state, n number of silicon atoms coming into interaction. So pause the video here and try to answer. So if you find the answer, please post in the chat or comment section. So let's now see what will be the answer. So here what they have said is the silicon atom is the first clue, and the second thing is the number of atom getting into interaction. So we know that the silicon atom's outermost shell is 8, and in valence band and in condension band, how many number of states is there is the question. So we know that the silicon is half filled. So we know the number of states would be 4 and in the condension band and in valence band. So the correct answer will be the option C. So continuing to this question, the next question is slightly modified. Consider the energy band formation in silicon when n number of atom interacts at T is equal to 0 Kelvin. So there is no temperature radiation or no electrons which jump because temperature is at 0 Kelvin. So then number of electrons, now note the word, number of electrons in condension band and valence band. They haven't asked about the states, they just asking about the number of electrons. So please pause the video and try to answer and post in the comment section. So let me discuss the answer here. So they clearly mentioned that they are asking about the number of electrons which is present in the condension band and valence band. So we know that there will be 0 electrons will be in the condension band and 4 electrons will be in the valence band. Based on the number of interaction atom, we are making that into multiple. So option is D. So I hope you got both answer. If you got it, then you are on the right track aligned with this series of lecture. If you haven't, please watch the previous video. There we have clearly mentioned how the process is happening. So if you guys even have any doubts, please post in the comment section. I will clarify you. So next, let's go into deeper into the semiconductor physics. So we know how the material, mass, charge, and other properties, how the energy bands are formed. Now, based on the concept that we have learned, how the materials is classified. So for this instance, let's draw a energy band diagram. So we are going to classify the things. So I'm just copying this one. So we will be having three different things, three different classification based on the energy gap or band structure. So let's take, as usual, we know that there is a conduction band and valence band. So there will be more number of states. So in order to represent that, I am representing this in a band structure, not as the normal energy levels. Okay, so this is one type of classification. Then another one level we have. So you can, even the diagram, we can see some gap between the condension band and valence band. So that is what responsible for classification of materials. So we will be going to in shortler. Okay. So this is what the energy band diagram which is represented. So this is E and this is the distance R. So same for all the things. So this is E and this is also E. So this gap is there, right? So this one we know that we will call this as a energy gap. So simply I will be putting EG. So EG, if it is approximately equal to 1 electron volt, then that is called the semiconductor. You have to clearly note it. So here, when the EG, the gap is greater than 5 and less than 10 or greater than 5, then we will call this as the insulators. So here the EG, which will be approximately equal to 5 to 10 EV electron volts. So this kind of things we call as insulators. So I think you're getting in the way, because based upon this length, the electron from the valence band cannot move to the condension band. So we need more number of energy, or more number of applied things need to be made to kick this electron from the condension band to valence band. Sorry, valence band to condension band. So that's why in insulator we won't be using that for the conduction purposes. But here if you see, here this is not the gap. Here you see up to this, it is what? It is valence band. This up to this is condension band, and up to this is valence band. You see there is a overlapping of bands. There is an overlapping. So here there is no Eg. Eg is less than 0 eV. So this is called metal or conductors. So best way to pronounce it will be conductors. Because in conductors we no need to give any kind of external temperature or voltage in order to simulate the current by external very forcefully, because it automatically there is an overlapping between the condenser band and valence band. So electrons can easily jump from the valence band and can produce the electricity or current movement. So that is what we have to understand from here. So everything here is CB, this is CB, and this is valence band, and this is valence band. So here the CB and valence band is overlapped. So that thing you have to understand. I hope this make you sense. So if you guys feel or have any doubts, please ping in the comment section. I will clarify you. Let's stay tuned for next lecture. Like, share, and subscribe the channel. Thank you.